welcome back. Today we're going to cover the next lesson in this honors geometry course, which will be 1.4. And if again you haven't looked at my last lesson about collinearity, I would highly recommend you do, right? But the lesson today is going to be about proofs and beginning proofs, right? Proofs are a major part of geometry, so it's really important to have good understanding of this lesson and really the entire process of how to approach them. But I don't want to waste any of your time, so let's get started. So, in order to do proofs, you first have to know what a theorem is, right? And a theorem is a mathematical statement that can be proved. Now, usually, theorems have a specific format that you will kind of recognize throughout this course. They usually have this if then structure, right? Where you have a if clause and then a then clause. Now, you're going to have to know around 100 theorems by the end of this course, right? So it's important that you start memorizing the ones that you are going to learn today so that you don't have to do it all like in one sitting, right? Um, But let's get started on our. Let's introduce you to the first theorem, which you'll have to know, which is if two angles are right angles, then they are congruent, right? So again, this is the first theorem that you're going to have to know. So make sure you memorize it completely, you write it down, do whatever you can to get really embedded into your head, right? So again, if two angles are right angles, then they are congruent. And to me, this makes like this is common sense because if two angles are right angles, right? Well, that means they have the same measure, so of course they're going to be equal to each other, right? But let's get started with our first proof question. So usually when you see a proof question, there are three components. The first component are going to be the first component is going to be your given, right? Or essentially what the problem tells you first. So for this problem specifically, it tells us these two given statements, right? Which is that angle A is a right angle and then angle B is a right angle. The next component is what you're trying to prove, right? So what conclusion you're trying to reach to. In this case, we're trying to prove that the two angles are congruent, right? Angle A is congruent to angle B. And lastly, the third component is the proof itself, right? Uh, it's the steps that you have to write down in order to reach your conclusion, right? Given in the problem. So now that you know the three components of a proof, how do you actually approach it, right? Well, whenever I approach proofs in my geometry class, right, I used to kind of use my own like 5-step process for solving them, right? So the first thing I always did was write my givens down, right? Write the statements that they give me in the problem, right? So let's do that. So over here, um, sure, let me just explain to you how a proof like chart even works first. So essentially, on the left side, you have your statements, right? And on the right side, you have reasons. You can think of your statements as the steps that you need to get to the conclusion, and the reasons are uh, the sentences or theorems um, that you need, right, or assumptions that you need to justify your steps or statements. But again, right, our first step is to write all our givens down. So in this case, we're given that angle A is a right angle B is a right angle. So what I've done here is I've actually written those, um, right? So I've written the statements on the left side, and then on the right side, the reasons for those statements, well, they're given, right? So you can just write given. The second step is to look at what you're trying to prove, right? So what statement are you ultimately trying to reach? In this problem, we're trying to prove that angle A is congruent to angle B. So we know that we have to find out some way of getting to that final statement, right? And quick side note, right? Usually in proof questions, you are given diagrams. Um, for this specific one, because it's really a simple proof, you're not really given any diagram here, right? They give you statements. They don't really give you a diagram with figures, but usually you are given one, right? So let's move on to the next step, right? So step number three is you have to find what you need to make your conclusion possible, right? What are the exact specific steps that you need to write down and justify for you to reach your conclusion, right? Now, in this question, you have a really simple proof, right? So there isn't really any necessary or extra steps that you need to make. You can jump right from the two given statements to your final conclusion, right? And the reason is, well, because you're trying to prove that these two angles are congruent, you're given that both of them are right angles. And we just learned about theorem one, right? Which is that if two angles are right angles, then they are congruent. So if you look at the if part of the theorem, right, all we need is for two angles to be right angles. And we already have that in the given that they give us, right, or the information that they give us. So we don't need to make any further steps. We can go right towards a conclusion, right? So number four was to write those steps down. Again, in this specific problem, we are really not required to write any extra steps down because we can go right towards a conclusion. So we can actually skip step four here, right? Uh, and actually, side note before I go into the last step, which is proving my final statement. Sometimes like you'll have proofs that have like 8 steps or like 10 steps, right? So it's just a matter of practice. You got to practice a lot of proofs. Um, so you can kind of recognize more patterns and like keywords to make it more tangible. But our last step for the proof process is to prove your final statement. So our final statement here is that angle A is congruent to angle B, right? And so you, of course, likewise, you write that statement down here, just copy it down, and then your reason is most likely going to be a theorem that you have learned in the past. Um, Now, so far, we've only learned about one theorem, but as we progressed in this course, you're going to have, like I mentioned earlier, 100 theorems. So it's good to practice them now so you don't have to pile them up and cram them all in one day. So our final statement, we can write down here, angle A is congruent to angle B. And then our reason for that statement, well, is going to be the theorem we just learned, right? If two angles are right angles, they are congruent. And that's it, right? That's essentially the entire breakdown of how you should approach a proof question in geometry. Um, One more thing I would like to add for this final step here, right? Of course, you wrote down the theorem, right? But sometimes people just like to kind of justify even more by like, using arrows to like point towards how they reach it. Again, you could do that. Personally, I don't do that because it's all done inside your head mentally. So again, those arrows are just for if you're more of a visual person. So let's move on to the next question, which will require us to know another theorem. And theorem two is really similar to theorem one. Instead of talking about right angles, though, we're talking about straight angles now. So very similar in structure, right? If then here, if two angles are straight angles, then they are congruent, right? Now, let's tackle this question again using that 5-step process, and I'll explain to you that process while I solve the question. So again, look at your givens first. In this problem, we are given a diagram, right? unlike the first one. So anything that you see in the diagram, you can use for solving the question. So we've done that, right? We have looked at the diagram. Um, Essentially, we have these two lines here, right? Those other colors and marks I made are just for like signifying some things I want to talk about later. But our ultimate goal here, right, the second step, is to prove that angle EFG is congruent to angle HFJ. So essentially, it's the angles I've indicated in orange. We're trying to prove that those are congruent. So now, moving on, what do we do first? Well, we've written down the givens, or actually, well, let me actually get to that really quick. Here, the diagram is the given, right? So you have to kind of think backwards from the conclusion. If you're trying to prove that these two angles are congruent, well, you have to first establish a relationship between them, right? That they are going to be equal to each other in some way, right? Now, if you look at the diagram here, if you look at angles EFG and HFJ, right, you'll notice that both of them look or appear like they're a straight line, right, or a straight angle. Now, that's an important thing to notice because in 1.3 I talked about assumptions, right? What you can assume and what you cannot assume in a diagram. A specific thing I mentioned was that one of the things you can assume are straight angles and straight lines. So here we can actually say for our first statement or our first and second statements that EFG is a straight angle and HFJ is a straight angle, right? Because we can make those assumptions since they appear like they are a straight line from a diagram. And our reason for that, well, you can just say given in the diagram, right? Or you can also say like assumed in the diagram, right? So now that we have established that those two are straight angles, what's the next step? Well, since we're trying to prove that these two angles are congruent, we just learned about this theorem, right? That if two angles are straight angles, then they are going to be congruent. Well, that's all you can do, right? You can just jump right towards a conclusion. You don't need any extra steps for this specific proof because you have two straight angles, right? You have shown in previous steps that EFG is a straight angle and HFJ is a straight angle, right? So you can jump right towards the conclusion and say that they're congruent. And the reason for that would be the theorem, right? Theorem 2, which is if two angles are straight angles, then they are congruent. So again, hopefully that made sense as to how I approach that specific proof question. But I can't stress enough, like it's really important for you to know and memorize these theorems now, so you can practice more with them and have more space left to like memorize other theorems, right? You don't want to cram everything in one day. Now I've listed 4 practice problems here, right? Feel free to pause. Actually, the first one we already did, right? But again, if you want to review, you can go through that problem again if you want to. But from these leftover 3 problems, you can go ahead and pause and try them out. But I'm only going to go over problem 4. So once again, I would recommend that you pause the video and try them out. Okay, so let's talk about number 4, and I'm going to use the process, the 5-step process. So let's first look at the question itself, and let's look at what's given. So essentially, what's nice about this problem is that they gave us the diagram and some statements, right? So we're given that angle ABD is 10 degrees, and that angle, we're given the lengths of these angles, or the measures of these angles. And they gave us a diagram here, right, for us to kind of visualize that. And we're trying to prove that angle DBC is congruent to XFE, right? So essentially, we're trying to prove that DBC is congruent to XFE, which is this entire angle there. Um, Again, I know they don't look like they are congruent, but remember, right? One of the first things we talked about is don't in assumptions is just because an angle doesn't look like it's equal to another angle doesn't mean that they're not equal, right? You can't assume that. But we're trying to prove that those two are congruent. So let's first write all our givens down, right? So statements 1, 2, 3, and 4, right? And also reasons 1, 2, 3, and 4. Well, all of these are going to be given, right? Because those are the same as given in the problem. So let's write those down, and actually I'm just going to copy and paste this to save some time, right? So once again, those are our givens. We have to write the givens down first. So now that we have written the givens down, right, what other extra steps do we need to take in order for us to get to that conclusion that these two angles are congruent? Well, let's focus in on what the angles are themselves, right? So angle DBC, right, that's referring to this. Well, you know angle ABD is 10 degrees, right? We know that angle ABC is 100 degrees. So this entire angle here is 100 degrees. So what can we say about angles DBC? Well, if the entire angle is 100 and this part is 10, right? If you subtract those two, you get 90 degrees, right? So you can say that the measure of angle DBC is 90 degrees. So we should probably write that down for our next step, right? Because that's what we can determine from the following information. So step number 5 here, right? We can say that the measure of angle DBC is 90 degrees. And our reason for that, you can say something as simple as subtraction, right? Because you're literally, what you're doing is you're subtracting 100 minus 10. And if you want, you can also say that, um, right? Say 100 degrees minus 10 degrees equals 90 degrees. Now let's do the same thing for XFE, right? We're given that angle EFY is 70 degrees, 20 minutes. And if you're not sure why I'm saying minutes, again, I would highly recommend you check out 1.2. I go over degree notation. And XFY, they tell us, is 19 degrees and 40 minutes. So here, they tell us 19 degrees and 40 minutes. So then what is XFE going to be? What is the entire angle going to be? Well, if you add those two, right, 70 degrees, 20 minutes to 19 degrees and 40 minutes, right? Well, these two here, they add up to 89 degrees, and these two add up to 60 minutes, right? Well, 89 degrees and 60 minutes is just equal to 90 degrees, right? Because remember the unit conversion, that 60 minutes is equal to 1 degree. So our sixth step here, right, we can say that the measure of angle XFE, right, is 90 degrees. And the reason for that, right, you can say addition. And once again, you can write the equation down, but for now, I'll just leave it as it is. So again, take a step, take a break, right, and then just look at this and see where do we go after this, right? After the sixth step, we're trying to prove that those two are congruent. We've already proven that both of them are 90 degrees. So because we're already shown that they are the same measure, you can jump right to the conclusion, right? And actually go on and make your final statement that DBC is congruent to XFE. And what's the reason going to be? Well, the reason was one of the theorems that we um, learned previously, and well, actually, I don't remember if he did go over them, but this specific statement can be justified by a specific theorem, right? Which is if two angles have the same measure, right? So if two angles have the same measure, in this case they do, right? Because DBC is 90 degrees and XFE is also 90 degrees, right? So if two angles have the same measure, then, right, you can conclude that they are congruent. So that's our theorem. If two angles have the same measure, then they are congruent. And once again, I've drawn arrows here just to represent that, to make it more visually understandable. And that's the entire process, again, for the proof, right? Just to review, right? The first step is to write your givens down. Then you have to look at your final statement, right? Look at what we're trying to prove. And again, usually you're given diagrams to help you with that. After that, you have to find the specific steps that you need to write down to make that final statement possible, right? And sometimes it's going to be a very complex proof. So again, it's just a matter of practice. Number four, right after you find out what those steps are, you have to write those steps down and prove each of them with a theorem or like a property, right? Uh, and finally, once you make all those intermediate steps, you can jump down to the conclusion, right, and prove that final statement with a, again, theorem or property. So hopefully that entire process made sense. And again, I would try these problems in your own time just so you get more practice, so you can recognize patterns better and learn when certain theorems are needed or applicable to certain scenarios. So thanks for watching. If you have any questions, leave it down, and I'll see you next time.